All right, Rams, we're going to be multiplying decimals today. Okay, I want you to think about what you notice about the number of digits in each problem here and the number of digits that are behind the decimal or to the right of the decimal. Okay, in this one, I have one digit that's to the right of the decimal, and my answer has one digit to the right of the decimal. So right here, the 4 is the only digit to the right of the decimal, so I only have one digit right there. Up here, I have 2 digits that are to the right of the decimal. So right here, I have 2 digits to the right of the decimal. Right down here, I have 3 digits that are to the right of the decimal, 3 decimal places. So my answer has 3 decimal places. That's basically all there is to this. Isn't that great? Okay, so we go right down here. Okay, we go to this problem here. All right, let's look at it. This problem right here has 3 decimal places. So when I would multiply these, my answer would have 3 decimal places, and it would be 0.301. Okay, this one right here has 2 decimal places. So my answer would have 2. So my answer, if I think about it, 6 times 25 is 150. You can use your estimation to see if that's a reasonable answer. 6 times 23 sounds like it could be 141. Okay? Right down here, I'm so sorry about the shadows in my room. I have 1 decimal place. That's times 1/10. Multiplying by 1/10 is the same as dividing by 10. So it would be 721 and 2/10, so 0.2. Right here I have 3 decimal places. So I have 1, 2, 3. So it's between the 2 zeros. That is 14 thousandths. Here I have 1, 2, 3. I'm going to have 1, 2, 3 and decimal. Okay? Over here to the left, why is estimation important when multiplying decimals? Well, you're going to write this down, and I want to see it on your paper, but it helps you to determine if your answer is reasonable. You're going to write that down, okay? Helps you determine if your answer is reasonable. Okay, how can you tell if your answer is reasonable? Well, let's estimate. Let's round the numbers like we did right here, like the 6 times 23, okay, 141. That helps you estimate, okay? Means use the whole number. 6 times 23, 18, be 138. 23 times 6 is 138. That would be very close right here, okay? This one, right down here, 5 times 1 is 5. If I had my decimal over here, and I know it's not a 7, but these are a little bit bigger than 5 and a little bit bigger than 1. So my answer should be a little bit bigger than 5 because 5 times 1 is 5. But if I had my decimal here and I got 71, I would know that it is in the wrong place. All right, so right down here, we're going to practice these. Hi there. All right, so we're going to start with our multiplying right here. Okay, 3 times 5 is 15. I put the grids here to help you out, okay? 15 and carry the 1. So we're going to multiply 3 by everything up here. 3 times 1 is 3, plus 1 is 4, and then 3 times 2 is 6. So basically, 215 times 3 is 645. Great. Now we're in the tens place. So we're going to need to add a 0 because anytime we're multiplying by a multiple of 10, we have to have a 0, okay? So what we're really doing here is we're multiplying 40 times 215. So I put a 0, and then I really go through and do 4 times each of these. So 4 times 5 is 20, and carry the 2. 4 times 1 is 4, plus 2 is 6, and 4 times 2 is 8. Okay, oops, sorry, my phone's ringing. It'll stop in a second. Okay, so I'm going to add these. 5 plus 0 is 5. 4 plus 0 is 4. 6 plus 6 is 12, and I carry the 1. 8 plus 1 is 9. So when I think about my problem and how many decimal places there are, I see a 1 and a 5 and a 3. There are 3 digits after my decimal in the problem. So my answer is going to have 1, 2, 3 digits after my decimal in the answer. Okay, but 2 times 4 is 8. So it's a little bit more than 8 because this is a little bit more than 2 and a little bit more than 4. So my answer is going to be a little bit more than 8. And 9 looks like it's a little bit more than 8. It's better than 92, okay? Next, right here, 64 hundredths times 7 hundredths. These are very small numbers, okay? Remember, like in a fraction, when you're multiplying something less than 1 whole times something else that's less than 1 whole, your answer is less than both of them. That means my answer is going to be less than 7 hundredths. Okay, so 7 times 4 is 28. Carry the 2. 7 times 6 is 42. Plus this 2 makes it 44. Okay, 7 times 0 is 0, plus 4 is 4. Okay, now I can go through and I can now also add, I can do 0 times 4, 0 times 6, 0 times 0, right? None of that really matters to me. But when I add them up, I get an 8 and a 4 and a 4. But my answer is not going to be 448. If I look at it right here, 1, 2, 3, 4 decimal places that are after the decimal, 4 digits. So I have 1, if my decimal starts here, 1, 2, 3, I have to go 4 places over here. So when I do not have enough digits, I can add a 0. Okay, and that's what this question over here says. What happens if you need more decimal places than you have? You add zeros. Okay, you add zeros and keep moving your decimal, and then you fill in the spaces with zeros. Okay, now we're going to be doing a couple of these in word problems for us, okay? So today in the cafeteria, 17 students bought pizza for $2.25. 34 students bought French fries for $1.50. How much pizza was, how much money was spent on fries and pizza? So we're going to rephrase the question in our own words. How much money did you spend? Or how much money, was spent? How much, I want to add the word total. Money was spent in the cafeteria. Okay, that's my own words. Okay. Now, my estimate. What if I said, let's round these. 17 students bought pizza for $2.25. So I'm going to say 17 times 2 is 34. That's how much money was spent on pizza, right? Now, we rounded that one down. I have 34 students bought French fries. Well, 50 cents says round up. So I'm going to say 34 times $2 is $68 on French fries. When I get a total here, $102 is my estimate. Okay, so my picture, I could draw a slice of pizza, and I could say this pizza is $2.25 times 17 of them. I could say my order of French fries, right? Does it look like French fries to y'all? Because I'm not much of an artist. My French fries are $1.50, and I'm going to order 34 of those. That's a picture. That's a representation for me, and that's okay. All right. Next is solving. So I'm actually going to do the real math now. This is actually using the real numbers because I estimated and I want to see if it's close. Okay. So $2.25 times 17. Now, does it matter which number goes on top when you multiply? No, because 3 times 4 is the same as 4 times 3. However, I like to put the one with less digits here on the bottom because that's less rows and less steps for me to do, okay? 7 times 5 is 35. Carry the 3. 7 times 2 is 14, plus 3 is 17. 7 times 2 is 14, plus 1 is 15. So now I'm going to move down here, multiplying the whole bottom row by 10. So 1 times 5, 1 times 2, 1 times 2. I'm going to add them up. Okay, Now, I had two decimals. In my problem, I'm going to need 2 decimal places in my answer. And you know what? I had a pretty close answer. I said about $34 was spent on pizza, and we got $38.25. Pretty good, right? Let's try the other one here. $1.50 times 34. Did you know that you do not have to put that 0 there if it's after decimal? It's the same thing. It doesn't change the value. It just gives you less steps. 4 times 5 is 20. 4 times 1 is 4. Plus 2 is 6. So 4 times 15 is 60. Good. 3 times 5 is 15. Carry the 1. 3 times 1 is 3. Plus 1 is 4. Okay. So I have 510. So right here I have 1 decimal place. So I'm going to have about $51 in pizza. Now I know it's not super close to this 68, but it's because that $1.50 was kind of right in the middle. Okay. Now if I want to add these up, $51 and $38.25, $89.25. And what did we say our estimate was? $102. That's pretty close. It's about $13 off, but it is an estimate, okay? Now, how did we know that this was multiplication? Well, because I could solve it with repeated addition here. I could